Okay, in this video we're going to solve simultaneous equations using what's known as the matrix method. So solve the equation 3x minus 4y is equal to 5 and 2x minus y is equal to 2 simultaneously using the matrix method. So we are trying to find where two straight lines meet. Okay, so let's write them out like we normally do. 3x minus 4y is equal to 5 and 2x minus y is equal to 2. Now, if we, the theory works like this. If we have a matrix times another matrix is equal to another matrix, then if we find the inverse of m and pre-multiply m by m to the minus 1, as long as we pre-multiply the other side, m to the minus 1 times m gives the identity matrix. For 2 by 2, that would be 1, 0, 0, 1. And on this side, we still have x and m to the 1 minus a. The identity times x will just give us x. So we can find x by doing m to the minus 1 times a. So if we now set this up into a matrix equation, so what we do is we take the coefficients, 3 minus 4, 2 minus 1, and then write down x, y, and then write 5, 2 as a matrix. If you notice when you do multiply matrix, you do row times column, so that will lead you back to that, and this will row times column will lead you back to this. Then if we let m be the matrix we get here, which is 3 minus 4, 2 minus 1, then we can find the inverse matrix. So if m is equal to a, b, c, d, the inverse matrix, m to the minus 1, is 1 over the determinant, so it's AD minus BC, times D and A. So D and A swap positions, and then the signs change on B and C. And provided the determinant exists, and if it doesn't exist, what you have is parallel lines or lines which are exactly the same line, then you can find the solution to the simultaneous equation. So our inverse matrix will be 1 over our determinant, which will be 3 times minus 1 minus 4 times 2. Then we take our matrix, write down, swap 3 and minus 1, so we've got minus 1 and 3, and then change the signs on these two, so we get 4 and minus 2. So this gives me 1 over 5, that's minus 3 plus 8 times minus 1, 4, minus 2, 3. And then if we take this and multiply this on this side and then this on this side, so going back to that, pre-multiply this side, and as long as we do it, pre-multiply both sides, then we can work it out. You have to be careful with matrix multiplication because it's not commutative. Right, now we don't really need to work this out. If we got this correctly, this here will just give me the identity 1, 0, 0, 1. Here we get x, y. This bit we do need to work out. Now leave the fraction outside and deal with the matrix multiplication first. Always do it that way. So you've got minus 5 plus 4. Plus 8, 4 times 2, and then minus 2 times 5, which is minus 10, plus 6. The identity times xy will just give us xy, and then we're going to get 1/5 of minus 5 plus 8, which is 3, and minus 10 plus 6, which is 4. Minus 10 plus 6, which is minus 4. And then finally, we can write down that x is 3 over 5, and y will be minus 4 over 5. It's important that you don't take that fraction in right until the last moment. Now, we can look at this geometrically using this GeoGebra applet, which I'll put in the notes of the video. Here we can see the meeting point 3 over 4 minus 4 over 5. And you can obtain the equations by moving the sliders, and here we have the working out here. If you were to click on this, you'll get the theory that I mentioned before. Okay, the interesting thing is a matrix multiplied by its inverse will always give the identity matrix. Okay, So this has been a video to show you how to solve simultaneous equations using the matrix method. I hope you've understood, and I thank you very much for watching.